Well, good morning, everybody. I'm going to leave you on this image for just a second as I explain to you what's going on here in this forecast video because I got it loaded with a lot of content. By the way, the image is from last night. This is the ring of fire of storms that's set up around this large ridge that's been slowly migrating back toward the west. So here's what we're going to do. We're going to talk about two different big ideas today, where there's been way too much water and where there's been not enough. We're going to talk about near-term drought. We're going to talk about what happened a year ago at this point, because this was a big transition time period a year ago, and see if we have something that's happening in terms of a transitioning pattern this year. I'm then going to walk you through the models. We're going to talk about the temperature pattern coming up, and then we're going to get out there into the longer range. So I've got new CPC data. I've got new data that comes out from the CFSV2 and the European model at the very end of this. And then I'm going to talk about a particular year, 2010. So if you're interested only in the long range, get out to these slides really quickly here because that's where we'll dig into some of that. I'll finish this up with an international outlook, and we'll also talk about the hurricane season. So it's the day after the solstice, which means this is kind of a critical time period in the forecast to try to see where things are going toward pollination for the main ag belt here. I'm thinking a lot about corn in this area, and we'll get to all that. So the animation, when we look at it, this particular pattern has some hope in it for some folks. And I want to start off with one area. It's this. National Hurricane Center gave this a 50% chance of developing. It doesn't really matter to me too much how much it develops. I don't think it can get into to become very strong. What I care about is its moisture, because so much of the southeast up the East Coast has been very, very dry as of late. We focused a lot on that this week. And if the moisture from this can get into Georgia or northern Florida, that would hit one of the driest parts of the southeast. Now, southern Florida has been extremely wet, but I'm talking about getting this moisture here. Secondly, this cloud shield here is all from Alberto, and as it moves farther and farther to the west, some of these clouds could actually get all the way over to California early this morning. But running around the periphery of that large ridge are all of these storms here. And we're going to see how much longer these storms are going to last. Could they continue to deliver more moisture into the Four Corner states, kind of an early bonus to the monsoon season. And then we have to just try to understand what the jet stream, which I've been making a case, is displaced north, where it's going to move over the next 10 to 15 days and possibly beyond. And what I'll be watching, because I live in the state of Illinois, and I'm in one of these really dry spots here as of late, is you can't quite see it, but way up here, coming out of British Columbia last night into Alberta, is a shortwave that I've got to keep a close eye on to see if it can sneak through the flow and deliver a frontal boundary that's going to take some of the moisture that's just been laid down in this area, extremely wet, and carry it into some drier areas. So that's where we're going with this near-term forecast. So this morning, if we just look at a radar animation, our biggest problem, if you just want to look at the who's been too wet side of this, was right in through here. We've got flood watches and warnings out because of how heavy the rain was last night, hitting already saturated ground in this area. So this is just a radar animation through early this morning. So many folks are waking up here with just standing water everywhere in this spot. Thinking about that, the National Weather Service on their all hazards weather map really has got a broad area of flood watches and flood warnings here, while the excessive heat watches, warnings, and advisories continue to stretch from the Ohio Valley into parts of the mid-Atlantic. The ring of fire is still quite evident, though. Can you see where the wetter weather is going to stay with this pattern by looking at where these flood watches are? In California's Central Valley, after seeing a couple of very smoky days from some large wildfires, continues to have heat advisories in place. So that's just this morning with the all hazards weather map. If we look back over the last 72 hours at trying to gather how much rain has fallen, parts of southern Texas, which were drier, rain. This was from Alberto. This is working against, in a big way, the drought that's in Mexico. We then take a look at parts of Kansas where the frontal boundary stalled out midweek, and the rains that came through here, also to the Panhandle, better rains in the Four Corner states, well, parts of them. And then right in through here, this is going to be the critical area to be watching as we go forward. Nice beneficial rains hitting parts of Montana. You can also see some isolated events that hit parts of the Northeast as well. But if I zoom in here on this part of the upper Midwest, there's going to be an important component to this forecast we have to be discussing, and that is how wet things have been in this corridor right in through here. So there's a term we often use when talking about hurricanes, especially down over parts of southern Florida. We call it the brown ocean, and it's where across the Everglades, across the southern tip of Florida, you can have so much water in the soil and in the vegetation that when a hurricane hits land there, instead of weakening, which it typically does because of the lands being so disruptive with friction and a lack of moisture. Well, down over the southern tip of Florida, we tend to get kind of this odd effect where the land actually continues to behave, for the hurricane's sake, as if it's an ocean beneath it. And why am I bringing this up? I was talking with my colleague Matt Reardon yesterday, and he used that term because he just went across I-80, up 29, and back across these southern counties of Minnesota. And he says he's just never seen the Corn Belt look in this area like he did. Now, I have not been up here in a while. My travels have been taking me to Canada, as you know. And I said, Matt, he goes, it is so wet and so saturated. And then this has fallen since he's returned. So if you look at those soil moisture values, this is a percentile, which means we're ranking this against the last 30 years of data. And what we notice here is that this large section of our western and kind of northwestern Corn Belt is just completely soaked. And I know a lot of times in this field, we kind of say, well, rain makes grain, but it comes a point where there is too much rain. And the too much rain, I think, is going to be a significant issue in this area. And I'm going to make a case for that. Meanwhile, take a look at Missouri, Illinois, Indiana, Ohio, getting all the way here from New York all the way down the coast, clear to Florida. This entire region has gone over very, very dry. Take note of this part of Oklahoma. It continues to get missed by storms. And this is an area that I think in the near-term forecast, like the month of July, has to watch out for significant heat and dryness. I'm going to tell you more about that in a few seconds. But as it stands, the new drought monitor finally started to reflect some of this dryness we've been talking about for the last couple of weeks. And that's how the drought monitor works, by the way. That's not a criticism of the folks that make this. This is a long-term cumulative statistic. So now they've begun to show where these abnormally dry areas are beginning to show up, and that's where the biggest increase has been in our drought monitor. It's all in through this region. Okay. Now from there, I want to show you a couple of maps. We've been looking at these all week. This is the last 30 days as a percent of normal. And we have parts of this western Corn Belt, upper Midwest area that have more than doubled up on their normal rainfall from May 20th to June 20th. Now that doesn't include what happened from like April 15th to May 20th, which we're going to talk about in a few seconds in this area. But just take note of this area right in through here that has gone drier as of late. In fact, I want to zoom in on that, just spend a moment here in the Corn Belt to show you some of the numbers here. So while we have pockets over the last couple of weeks, the last 30 days, 4 weeks, that in parts of Minnesota and Iowa coming out of Nebraska are like 200 to 230% of average, we've got several places in here that have seen less than half of the normal rainfall. And most of Indiana and Ohio have been very, very dry. Now, we'll talk about the Southeast in a few moments, but you can also see right here in Oklahoma how things have been dry in that little strip. That's a huge strip of land right here as of late. Now, why I'm thinking hard on this is because look at the time period that led up to this recent wet go of it. From mid-April through the beginning of June, much of Nebraska, the Dakotas, Minnesota, and Iowa, including Wisconsin as well, were exceptionally wet. Now, we spent a lot of time talking about how wet things were in the Mid-South and how wet they were in parts of Texas here with just nearly constant storms. But I want to take note of this and just make a case for what's going on in this part of the country. So I went out here to Algona, Iowa, which is kind of right smack dab in the middle of this, where that number 1 is located. I mean, the wettest April 14th through June 1st time period on record, and our records go back to 1893. So I went in there and I just pulled up some of the data, some of the stats from agweather.com. So first of all, they're at 172% of normal precipitation on the year. And if we zoom down here to the bottom, what you can see is where their current year's precipitation compares to previous years. Now, for many of us in the Corn Belt, 2019, I'll kind of flash it here for you. That was our incredibly wet year, and we are way above that through this point in the year. You think about last year, we'll kind of flash that one as well. This particular spot was, if you just see the line in here, was actually in the middle of about a 35-day stretch of no precipitation at all. That was actually going to extend to almost 40 days at one point. We are nowhere close to that. And even one of our drier years, like 2022, take a look at that, I'm flashing it. We are already about 8 inches wetter than all of 2022 in this region. And this is just one spot up there. So just thinking about what's happening in this area, all of this extremely wet weather has forced farmers to make some really tough decisions about what to do with the crop. And I also pulled this up. because of this break that happened at the very end of May, I think there was some rapid planting at the end of May and replanting. So I decided, using a tool I've built, to create a forecast of the GDDs for 100-day corn planted on May 30th, which some of it was planted that late in northern Iowa. Now, I don't know if that relative maturity is correct, 100-day corn, if you'd plant that in late May. But if you did, you would have a silking date start time around July 29th, July 30th. But unfortunately, 100-day corn would reach black layer right around the climatological average of the first frost, which is here. We've had years where they've been earlier and later, but this is a very vulnerable crop because of being planted so late. And that's not to understate how incredibly wet it is in this area and what that's done to the early crop stages. Now, a year ago, this wasn't the case. I mean, a year ago, this pattern looked entirely different. There was a massive ridge that sat over Canada. Flow came out of this direction. We just soaked the plains. Keep that in mind a few moments here. And the southeast, stalled out fronts down here, kept things really, really wet. So we were dry in the northeast. Upper Midwest, Great Lakes states, extremely dry. And then we had this reverse rain shadow effect, right? So if the flow came over the Rockies this way, the rain shadow's now on this side of the mountains. And just to show you what happened, a year ago at this point. So what about the southeast? Well, if we take a look at the last 30 days in the southeast, expansive dryness, all the way from, Pennsylvania, New Jersey, through Maryland, straight down here through the Virginia, the Carolinas, Georgia, Florida. This particular region has just missed. We've not had the flow. The jet stream's been extremely weak over this area. In fact, I'd like to go look at some of the weather balloons that are launched to see how far they travel away from where their launch point is. I bet it's not very far at all because of how dry it's been in the upper levels of the atmosphere with no wind up there either. So thinking this all through, this really just highlights the importance of this potential tropical system here, which the National Hurricane Center this is the 1:30 update. I don't know if they've done a new one yet or not. Nope. The 1:30 a.m. update has given that a 50% chance of developing. Now we have another to talk about, and that's over here where there's a 60% chance of this next bit of convection going over the Yucatan, where it might go. But this guy right down here is important. And some of the models are suggesting, so there's the circulation early this morning, that we could be bringing in some scattered rainfall. And this is what the high-res NAM is doing. Let's go back and watch it again. So coming right there, almost around Savannah, weak system, but man, if we could get the rain out of this, that would be critical in that area. So we're going to have to watch this all weekend long to see how much moisture can be pulled in some really dry parts of Georgia. But this by far does not, wipe out the drought risk that's in this particular area. As far as the other system, just want to point out that it's pretty disorganized in where we think that could go, but it does appear to be another, event that's going to help work against the major drought that's in Mexico. And if you just kind of look at why this is, we've seen really good trades just pushing into this area. The trade winds have been quite strong. They've taken advantage of what's called the Caribbean gyre. That's this low pressure that can tend to form in this area. And we're just pushing that moisture into Mexico, erasing a drought in that area. So that's just the beginning of where this pattern is now. Let's talk about where it might go. So I want to show you a few maps. The next few maps are precipitation anomaly maps, 3 of them. This is the next 7 days according to this morning's ECMWF operational run, not the ensemble, but the operational. And we kind of see a lot of the same thing. Remember, these colors are drier, these are wetter. If we add to that the week 2, this is what week 2 looks like, and it's shared by most of the models. And it looks quite active, but there's an area that's beginning to really show up as a major concern for me. And it's here, and I would just kind of say coming back into this region as well. There seems to be, because of the northward extent of the jet kind of flowing across the country like this, there seems to be the ability for the atmosphere to kind of walk a ridge back and forth in this area over the next several days and possibly weeks. And what that is potentially going to do is to send a region that has been of major concern as of late of going over very dry into greater and greater drier risk. Now, if you put a ridge back and forth in through here, you're going to get flow around it. You're going to get flow like this, and there's going to be lots of storms that roll around the edge of this. How far to the south do these storms make it? That's the question, because I think we're going to open up a stormy corridor in through here. But do they make it clear to the Ohio Valley into the Mid-South? And does this dryness anchor around the confluence of the Ohio and the Mississippi, or is it back toward the Red River? That's a big question. And then if that ridge does sit in this area, what happens on the eastern side of it? Because honestly, the flow around like this direction is not good for the drought situation here either. So I have a lot of concern about where this pattern is going to go. But if I show you that third map, it's all of it put together. So this is a 14-day forecast of precipitation anomalies. I'm going to come back to that brown ocean idea. All of this moisture hitting this region, saturating the ground, it can be moved. Just in the same way we move Gulf of Mexico moisture, we're going to see how this moves. And I want you to think about that going forward. At the beginning of my video, I talked about a couple of areas of hope, right? So we saw for those dry regions, maybe the moisture coming in here from this next would-be tropical system. But the other piece I'm watching is right there. You see, this is the flow today. And the jet stream still coming across the Pacific as it's been doing for months. There's a weak little shortwave here, and there is our broad ridge feature, okay? Now, this shortwave right there, I just put a line through it. I'm going to watch carefully to see if it can sneak through the upper Midwest, grab some of the moisture that's in the western Corn Belt and deliver it into the central U.S. because there's some spots there that need the moisture. So we're going to watch how this evolves by first starting off with today's convective outlook. It's 100% ring of fire. Can you see it? Right there. As we get into tomorrow, this is what I'm watching. And then into the next day. So that would be Saturday, this would be Sunday. Can you see the progression? Saturday to Sunday. Something is moving across here in the form of a front. And I want you to see how this is going to work out. The high-res NAM was well initialized this morning, in my opinion. You can see, look, I just rock back and forth. That's ring of fire to the T. And as that continues to form, what I'm curious about is right here. Now watch, this is Friday night, possibly a very, very heavy rainfall coming back into this area, more flooding, storms in the Four Corners, northern plains, running right along the periphery here. And then as we play into Saturday, here it is, Saturday afternoon and evening, what I will want to know is this front really going to drive into Michigan, eventually Indiana, Illinois, back to Missouri? And as it does so, can it stick together long enough to deliver rains into those dry parts of Illinois, Indiana, and Ohio, and then eventually farther to the south here? So there's the front we're going to watch. A lot going on with that. Okay, from there, pattern. Ready? This is the European artificial intelligence. I have been impressed. You know I've been impressed with it. Let's continue to see what it does. This is the trough I'm watching Saturday, Sunday. As we get out there to early next week, where did the ridge go? It's now moved itself here. And the flow just lives on the U.S.-Canada border, almost outlining it perfectly. And what this is going to do is that's going to keep a very stormy corridor in that area. Now, as you think this through, each time one of these short waves interacts with the interacts with the moisture that is in the atmosphere here and in the ground, will it be able to initialize storms that roll down through this corridor? That's what we're all trying to figure out for the main ag belt of the country. But I'll just say this, through the end of June and into July, I see a lot of ridging happening here, which is why I've got this area pegged as possibly having the risk of being not just hot continually, but also having the risk of drought, not just flash drought, but kind of longer term drought settling in. Because the farther out I play this into early July, I see just more ridging in this area with the jet stream just fueled, but north. And that northward shift of the jet stream has been a main topic I've covered now for weeks. I think it's going to be critical to understanding who's going to get this rain and who's not. So that whole narrative has not changed. So let's now see what it's doing. AIFS, this is the Artificial Intelligence Forecasting System from the European model. Better chances have shown up in this area as of late for rainfall. Still very dry in parts of the mid-Atlantic down to the Carolinas. This is the moisture from the tropical system we might possibly get into parts of the southeast. But around the Red River Valley, this is where the models have gone over the driest. But if you put high pressure here, okay, so let me show you this. If we put this high pressure, see the flow? We keep bringing moisture into the Four Corner states for some early monsoon. Canadian Prairie continues to stay wet. This is actually not good. We've got to dry this area out. They've got to get some heat in here, and they've got to get some sunshine in here. We've not seen it. Remember, we talked about the frost earlier this week in parts of Alberta. So that's one model. Let's go look at the NBM. Very similar setup, but now improving the moisture, the better chances for rain in this area. Driest here. driest there. Let's go look at the WPC. Very similar to the MBM. And next, the European. Now, what's interesting about the European model and the GFS is that they are both trying to deliver some better rain into this area. And we'll look at how they're going to do it in just a few moments. But I wanted to again show you the GFS, and then I want you to watch the GFS. This is the 0Z run. So here we go into tonight, playing through the weekend, and everything through here makes a lot of sense, right? We've seen this. But what's curious about this is that next Monday, Tuesday, Wednesday, right there, there's another frontal boundary that sneaks through. And I'm going to be honest, we need the GFS to be right about what's going to be hitting this area and a bit wrong about this region. We need less here and more into this area. But it's my point that we're going to get these thunderstorm complexes that roll through this corridor. And some of the models are beginning to show that. And watch, we're going to add more to this as we get a bit farther out in the forecast. Now we're out here in La La Land with a model. But the idea is storm complexes will form. The problem is they're storm complexes. They're going to have heavy rain in some spots and they're going to miss others, which is why each day I always start off with looking at the most recent precip. So with all of that, let's go in and have a look at the two models compared to one another, GFS left, European right. As we play through tonight, again, we're just going to watch through this area, the heavy rains hitting this spot. We get out there Sunday into Monday. Early next week, Tuesday, this is what I'm going to be keeping an eye on. Big front sneaks through. Now look at this. This stormy corridor really needs to manifest itself to deliver rain into some dry pockets, because behind it's a big area of high pressure and cooler conditions. Next Thursday, I've got to watch very carefully to see if some rain can get into parts of the southeast where it's been so dry. As we play this out there to Friday, you can just see where the storms are rolling right across the U.S.-Canada border, and that's where they're going to continue to form. Late in the forecast, the models leave a lingering front over parts of the southeast, at least the European does. We need to see if that can actually deliver some moisture. But remember, these are operational runs. That's why we always look at the ensembles. Over the next 7 days, who has the risk of being the driest? Well, it's going to be down here around the Red River, getting into this part of Texas. And then we're going to watch the Ohio River Valley toward the Appalachian Mountains and then into parts of the Atlantic coastal plain. On the wetter side of this, I bet I got to do model run in. Yeah, let's go back and flip that. On the wetter side of this, let's just take you out 10 days. This corridor stays exceptionally wet, as does this. Better storms in the Four Corner states, but we have to just watch for those storm clusters, those storm complexes to roll through this pattern and maybe hit some of these drier fields that are here in Missouri, Illinois, Indiana, Ohio, Kentucky, Tennessee. My greatest risk, in my opinion, is down here for where we're going to be going over drier. All right, what about week 2? You can see that the European and the GFS have very similar outlooks, right? They look quite similar. And we know that the GFS has a known drier bias here. The CPC, their new forecast, is just more, it's not reflecting that dryness that I think we're seeing in some of the other models. I want to see if their update today, they're going to do this a bit later today, starts to include more dryness in this area. And watch it carefully. But it is pretty consistent that from the 28th through the 4th of July, the upper Midwest stays wet, and we're going to see an active monsoonal start to the monsoonal season, although it's really just being driven by big high pressure here. Normally we wait until we fully get into July and August that the monsoon kicks off. Temperature-wise, I just wanted to show you the last month or so in terms of temperature anomalies, and this again just makes the point I've had all a month long, honestly, is that the Jets is just living here, right in the contrast between where there's cooler and warmer air to the south. Frost map, finally almost all clear today. If we go out there and look at where these high temperatures are going to go, this is today's high temperatures, quite cool in the upper Midwest under that cloud cover, northern plains, heat building back into the west. This is all cloud cover, cool. I just want to make a point that earlier in the week, some of the forecasts here were for much higher temperatures deep into the 90s. They backed off a bit on that. Saturday was supposed to be our very, very hot day. It still will be hot, but these numbers are now down here in the mid-90s rather than upper 90s. And then you get out there to Sunday, warmth pushes into the Central Valley of California. Monday, it's going to be a hot one in the Central Plains of the United States. Tuesday continues, 101 in St. Louis on Tuesday. By the time we get out there to Wednesday, though, see the cooler air trying to work its way in. And that's what the GFS has kind of said all along. It's had this day 5 through 10 trying to bring in, remember that jet stream pattern's doing something like this, is trying to deliver cooler air into this area. And to be honest, I discounted it earlier. You know, I said, I think the GFS is not right. I think there's not, well, I got to walk that back a bit, because there's been more consistent, information about the flow of the jet behind a trough that's going to go in through this area, delivering some cooler air. Day 5 through 10, though, day 10 through 15 looks something like this. So the European model showing that for day 5 through 10, just take note, the GFS was cooler into this area than the European. And this goes out there through day 10 through 15. And it's this contrast that we're going to watch all summer long, I think. Okay, that is your 2 weeks. Let's go beyond this. July 5th through June 11th, the CFSV2, no change. See where they've got the heat versus the cool? July 12th through July 18th. Again, anchoring the heat over this region, shot of cooler air coming in. What are they doing in terms of precip? Still stormy and wet in this corridor, and it just stays there through July. And if the CFSV2 is right on this, that's a major, major concern I've got for this region, and why I'm looking back at 2010, which we're going to do here in the last few minutes of this video. So that would be July 5th through 11th, 12th through the 18th. What about the, what does the European model say? The European model, I'm going to take it and modify it. I think we do end up seeing more ridging that lives here. It's going to flex back and forth, but it's going to stay there. That's what's helping to drive this. But what's not being resolved is where the storms will cascade over the top of this. What's interesting is the European model for July is trying to keep this whole region wetter. And without getting some sort of influence of a Bermuda high or some sort of just better flow into this area, I've got to call this into question. Is it biased too wet in this part of the southeast where we've been so dry? I'd also say that the Canadian prairie is also biased way too dry in the model. This is the one spot that I'm on the lookout for. That's the spot that I think we could get the greatest risk of rapid onset of drought and heat. That, in the European model, take a look at the 30-day temperature outlook. That is where they anchor the highest temperatures. I think this is too warm. Okay, another piece to this. This is what the CPC released yesterday. This is their new July outlook. Now, I think when they created this, there was several things like the PDO signal that was being examined, also the La Nina, which is still very, very weak, if almost non-existent, and the fact that the pattern started off so dry here. I think they continued that, but there is risk. But I was a bit surprised that they didn't place this high pressure this high temperature epicenter more here. It feels to me like a lot of their July outlook was mainly kind of like right now, not necessarily later. They also, they did update their seasonal forecast as well. This is their July, August, September. And I mentioned at the beginning, we're going to compare models. I don't really need to. This is what they all look like. The CPC looks like this. The European model looks like this. The NMME looks like this. The IRI looks like this. We've been examining these all for the last couple of weeks, and they all have this same look. And I'm not really giving any of them much credit at this point at really picking up on this. So here's what I want to do. I want to show you something. This is our current ocean temperature pattern. We spent earlier in this week talking about the Atlantic meridional mode. We know that we have bits and pieces of a PDO signal, but this warmer water sloshing its way in through here, making it into this area, has, I think, been a component of keeping the jet just living across the northern tier of the United States. La Nina, honestly, while there's been some stronger trade winds, it's not necessarily yet a factor. In other words, it's not stealing momentum from the northern hemisphere. We still have this negative PMM thing. And then here in the North Atlantic, that needs to be watched. The reason is this pattern is fragile in that we could develop at some point a triple ridge. And right now my thinking is that ridge lives here over the Red River Valley toward the lower Mississippi River Valley. There's been times where the triple ridge puts this over Minnesota. Been times that it's put it back over Montana. I think this year it's going to live here. So a year I want to compare to is 2010. Now you're going, why? Look at the differences. 2010 had cold water here and was much colder, major negative PDO signal and stronger La Nina. But there was the warmth in the Atlantic. And if you look at this year's ocean temperatures and compare them to the global average, which is what this graphic does, there's a bit more similarity. Now, why do we do this? What's relative? We're just trying to see the relative differences. But I want to show you something. This is not here. There was much more warm water displaced farther into the North Atlantic in 2010 than this year. So I want to show you what happened in 2010 that's got my attention, because from mid-June all the way to the end of August, the upper Midwest never stopped. We got really dry in areas that have already been quite dry. California went hot and dry as well. So what I'm worried about is if this continues, do we just go all the way through summer with incredibly wet conditions in this area? Well, what happened in 2010 was, I don't want to show you that one. I'm going to show you this one. This is the flow. Find North America, it's here. Ridging event, deep trough, ridge, trough, and then where did the ridge go? Went way up here. Now that particular year, the ridge at times anchored right over like Kentucky, and the flow came around this all summer, delivering all that moisture into this area while keeping the Canadian prairie cool, parts of the Pacific Northwest cool. And don't forget, this was the same pattern that drove this massive blocking setup over parts of Russia, with a huge ridge here and a trough there. And this is what drove major drought into the Russian wheat belt. Now that's what happened in 2010. And I think there are flavors of that this year, because this is what the summer precipitation pattern looked like. We had incredibly wet conditions in the upper Midwest, drier through the Ohio River Valley at times and then into the southeast. There's the drought that hit the Russian wheat belt really hard. But you can take note of a couple of the things, like look how active the hurricane season was during that time. Now, thinking this all through, I want to show you this. It's a point to say we're not quite there. There are differences. Over the next 15 days, we're not looking like 2010. But should this ridge move its way here, and should this ridge start to move its way back, we get this trough to kind of flex in here a little bit, and that ridge comes in to replace it. So if those subtle changes happen, we're into 2010's pattern. And guess what? This ridge moves right back over this part of the Russian wheat belt. As it stands, what you need to take away from this is that the flow pattern looks something like this. And that is a pretty far to the north extent of the jet stream. And it's going to probably stay there for a while. So there are hints of 2010 in this, but I don't think 2010 is a perfect analog. But you now know what I'm watching for. Watch for the movement of these features going forward. Now that particular pattern, the one that's really going on right now, is driving this temperature outlook for the next 10 days. And it is cooling down in a couple of key areas, like here, and also right in through here. And if we look at the precipitation pattern, though, the European model is still drier in Ukraine, but it just, in today's run, went wet across key areas of Russia that have been extremely dry. But you got to be wary of this. You got to look at that and go, okay, for real? And some other models, not buying into it. This is the newest run from the artificial intelligence. Ukraine, much drier, not nearly as strong as a signal for being wet in this region. So I just want you to keep aware of those things. One last thing to talk about. If we look globally here, actually two more things. This is the newest satellite-derived vegetation health index change map. And if we just kind of click on it, remembering that these colors represent degradation, these represent better than a year ago, I want to point out a couple of things. Let's start in the U.S. See this? A year ago, things were much greener in this area. This is what the wet weather's doing. Same thing here. Last year, we were extremely wet here, which means wet in the high plains makes things much, much greener. And that's why we're seeing the degradation in that area. This is the Mexico drought, which lately has been getting a cure, but you can kind of see the issues in parts of the southeast showing up with the degradation as well. But take a look at this part of Ukraine into western Russia. Look at the lack of early season monsoonal flow. This is getting some big cotton acres, for example, right here. We got to watch these things very carefully. Now my last thing. I was looking this morning at how much dust was coming off the Sahara, because we're, I think, about to get into what could be a very active hurricane season. And there's quite a bit of early season dust, but when you see dust coming off of the Sahel, off of the Sahara, north of the Sahel, sometimes this is an indication of early active convection in that area as well. And one of the other things I want you to think about with 2010 was it currently ranks third behind 2005 and 2020 in terms of hurricane activity. And notice early in the season we had a lot of this going on. And later in the season the tropics got going. But remember, in 2010, the ridge built way up here, which is what curled these around. If we build that ridge closer to the U.S., we could push more of these into the Gulf. So that was a lot, but all of these things, I've got to keep looking at them all weekend long. There's too much moving right now in this pattern to nail it all down and to say that it's set. But you know the things that I'm most worried about. So I'll watch it over the weekend. We'll talk next Monday. Have a good one. Thanks.